My name is Philippe Ciais, and I'm the coordinator of this Sealand project. It's a project which is lasting for 10 years, and it started already 6 years ago. And every year we have like a general meeting, which we try to have it more scientific than just financial or administrative. So welcome to this 7th General Assembly, as we call it. For those who don't know, Sealand, it's what we call a virtual research institute that gathers several teams. All the teams are in the Paris-Saclay campus that is around. And the kind of scientific mission of Sealand is to study the food climate diversity nexus. I guess all of you know that well, the land is used for producing calories and wood fibers. And this leads us to consume resources, some of them being in finite amounts, in particular water, but also nitrogen and phosphorus. And those three compounds, they are used by mainly agriculture and forestry, is leading to cross what is called planetary boundaries, which means an excessive human footprint on the Earth system, as well as a loss of biodiversity. And at the same time, the climate treaties, mainly the Paris Agreement, is asking the same sector to reduce greenhouse gas emissions. The land use greenhouse gas emissions altogether, methane, nitrous oxide, and CO2 from land use change, I think it's responsible for about more than 1/3 of the global human emissions. So keep in mind that there is no 1.5 degree and no 2 degree scenario without a very strong reduction of greenhouse gas emissions by land systems. And somehow this climate goal of reducing emissions might be somehow in conflict with the need to continue to produce calories and the use of the resources that are associated with it. And this is those trade-offs and potential co-benefits that we have been looking at in Sealand. The project is organized into basically 3 main research topics that we call challenges. One of them is to quantify at regional and global scale what are the options and the cost of land-based mitigation options. The second one is more looking at how climate change has impact on the production. As you know, it's mainly a story about climate extremes because extreme heat waves, drought, but also flooding can produce, let's say, abnormal drops of productions of everything. And the third challenge is integrating, also with models, the results of the 2 previous ones. It's good to do research, but we need basically, and I think this is not only a problem of Sealand, but all over the globe, to train a new generation of scientists that come from different backgrounds, physics, mathematics, economics, biology, to be able to tackle those new problems. And that's the reason why we developed a graduate program, basically to help train students on those emerging topics that do not have, let's say, established schools, like doctoral schools at universities. So as I said, the project since the beginning is gathering a large number of teams. On the paper, more than 100 scientists are involved. Some of them are, of course, very active in the day-to-day organization of the project. Others are, affiliated or associated. And although it's a relatively large project, it's clear that it's not Paris-Saclay alone that will solve the problem of the global food, climate, and diversity nexus. So we've been working all along with partners in France, of course, but also in Europe and at the international level. Working with means co-supervised students, joint projects, invitation of people. Don't be afraid by the organization. It's not the Politburo, it's just that as for every large project, we have a scientific steering committee. We meet regularly every month and we look at progress, but also new emerging scientific topics that should be addressed by Sealand. And then each of those topical challenges, mitigation, impact and adaptation and integration towards like new pathways and optimal production systems are coordinated by a subset of these steering committee members. But the most important is not the top of the pyramid, but the young researchers, PhD students, master students, postdoctoral students, basically you in the room, and others who have worked and left Sealand, who have been doing great research to bring up the project, I think, to a very good recognition, both nationally and internationally. Usually I start with the research, but today I want to start with the graduate program. It's coordinated by Erwan Persson, but he's not here today. So what did it do recently? So the graduate program is basically a committee that organizes activity around training, more particularly training by research. It facilitates the funding of master students. The vision here is that we can support in different teams through applications, master students, in order to identify those who are willing to continue with us and to do PhDs. There is also an involvement of all the students in this campus and around into some of the scientific animations and thematic workshops that we organize around specific topics in Sealand. And this year, we also funded like a field study trip for students of Agro-Paritech. We didn't report about this participation of students. It's already 1 year old. It's a previous COP, but Sealand also supported the travel fees, some travel fees, for a group of students who have been in Sharm el-Sheikh in Egypt at the previous COP, and they not just participated as observers to the COP, but also they produced a report and they organized a workshop to share their kind of conclusions and impressions. It was not just tourism, but also real work that was associated with that. And beyond the kind of physical support to master and PhD students, Sealand and the community as a whole has been active to provide some online material, basically short e-learning videos that have been increasing in number around all the topics that are in fact widely used. We have a lot of visitors and people who download or watch those simple tutorials on a number of precise scientific questions addressed by Sealand. As I said, I think more than 15 master grants have been funded by Sealand. And also the graduate program is helping to support new PhD topics. So it's an open call every year. We finance about 6 to 7 PhDs. To be fair, I must say that we give half of the funding and we ask the applicants to find the other half. So we generally receive about 30, 35 applications for topics. And there is a first selection of projects which we believe are in the scope of the project, and then we have auditions of proponents, sometimes candidates themselves, and we have sponsored 6 PhDs that will start this year, and I'm sure the challenge presentations will mention them. Then we have developed over time several research projects. It's not so easy over 10 years to keep the momentum. We are already at year 7. We cannot just say, okay, we give money to study mitigation, blah, blah, blah. So we try to revamp a bit the research agenda and to define, let's say, a larger number of research projects. Each of them is associated 1, perhaps 2 postdocs. And we wanted to avoid the typical working in silo, that if we have a mitigation challenge, they do only their research and they don't talk to the adaptation. So we try to make it in a way that those research projects would involve researchers not only working, for instance, on mitigation, but also on adaptation and integration. I don't have the time to list all the topics, but you can get a flavor of the projects that have started last year, and some of them are a bit late. They will start only this year. They deal with a large diversity of topics, like the impact of land abandonment, but also production losses from climate disasters, which has been since the beginning a very important topic of Sealand. And in total, we have now 11, let's say, cross-cutting topics, hiring young postdocs. The results of those projects will be partly presented by the challenges, and we hope to be able to organize like a kind of day of those Sealand projects where all the young researchers themselves will be able to meet together and present more details their projects. We do have a lot of research publication. I think that's one of the big kind of positive outcome of Sealand. Is that compared to other similar projects, our effort has resulted into a significant number of new publications, many of them being in high-profile papers, including Nature or Science. Up to now, after, let's say, 6 years of operation, 7 years of existence, but because of the administration convention and so on, we only have like 6 years of, let's say, operational research so far. Please, if you write publications within Sealand, don't forget to add the acknowledgement, because otherwise, when we look for, web database of publications, we're not able to know if your publication was sponsored by us or not. Don't have time to show the wealth of results. I just picked a bit arbitrarily 3 highlights. One of them is nice because it's really a Sealand effort. Bertrand Guenet organized a workshop about, let's say, emerging challenges in soil carbon models. And Julia Lenoé, she wrote a very nice perspective in Nature Communication in Earth Environment. The title says it, is that soil carbon models need independent time series for validation, because she found, quite surprisingly, that soil carbon models, it's a data scarce world, not too many data. They usually use data for calibration and then they do prediction, but they don't have the practice, maybe the ability through lack of data to do like independent cross-validation, in particular for the temporal changes of soil carbon, because long-term time series of soil carbon that are representative, of course, are very hard to find. Second challenge, a paper by Rose Abramoff, who now left to the United States. His work was mainly inspired by David Makowski and his colleagues from Japan. They had made a large compilation of crop model predictions from typical like AgMIP project that run their models at different sites. So every site you have wheat, for instance, and you predict for a range of model, a range of practices, the future of the yield or the response of the yield to climate. The interesting thing, I mean, there are many such data sets, is that some models included adaptation, whatever it is, irrigation, changes of cultivars, changes of fertilizers, and some models did not. So it's the unicity of the data set is to have adaptation and no adaptation runs. And then Rose and David tried many different statistical models to explain the data. What is interesting methodologically is that some models belong to machine learning, like random forest. Some models are more like linear mixed models. You always think that machine learning does better, but in fact, for some crops, linear mixed models were doing better than random forest or gradient boosting. And then Rose was able to provide an upscaling of the future yield losses for here one given climate scenarios. The most interesting part is that you have on the top row the kind of total yield loss without adaptation. I think it was very large, in particular for crops like maize. And the reduction of this loss when you include adaptation. So this was the first time that we could provide an empirical map of the kind of alleviation effect of adaptation on yields. And the last study I would like to highlight, because it was also a very large collaborative study that in fact started just at the same moment than Sealand, called Stimul. It was led by Raja and Paul Ledley and others. The idea is to ask a combination of, let's say, plant economic models and biodiversity models. What happens if the European Union decided to decrease by 2 the amount of nitrogen input in agriculture? The results were studied with 2 types of land use economic model. One of them has the possibility, if you don't have enough yield, you can cut forest and get new cropland. The other, arropage did not have this possibility. It's just kind of reallocating land between, I think, production and fallow. But the important thing is the colors in the metrics, which explain the trade-off. So when it's purple, it's very bad. You decrease the nitrogen, you have bad effect on 2 variables. When it's orange, it's half-half, like one variable is badly affected, another is positively affected. And when it's green, you have co-benefits. So reducing nitrogen is good, like for water pollution and biodiversity, for instance. And the important point, as Raja outlined to me, is that, of course, you have very large differences between the 2 models, which itself is of interest, is that overall, the study showed that having nitrogen input in European agriculture has more benefits than cost. And I think this is a kind of high-level important message for common agricultural policies. Now, last, I want to give you some innovation of something we don't speak too much about Sealand, is how we have worked, at least some of us, with companies to develop, let's say, interesting things for the private sector or with the private sector from research. Here, Hassan Bazi is working here. He's an employee of a data company called Atos. And Atos has funded 4 PhD studies with us. And they give them permanent position. So it's a good deal, because they put them in labs, they give them a permanent engineer position at the beginning of the PhD, which is very good for the candidates, and they do research for 3 years. And Hassan has been developing a kind of simple model called VPRM to predict the CO2 fluxes over France. The novelty of the model is that it is based on the Sentinel-2 data, and the Sentinel-2 data are satellites that have a very high or rather high spatial resolution of 10 meters. The advantage of 10-meter resolution is that if you have crop, forest, and grassland in the landscape, you can sample only the crop fields and the grassland and the forest. Then you aggregate, but you are sure that you have a purity of the spectral vegetation indices out of which you predict CO2 fluxes, which was not possible with moderate or coarse resolution sensors like MODIS. And as you may have seen in the animation, we looked at 2023. So we built a near real-time analysis system of CO2 fluxes. And we saw that in 23, nothing happened significant, except for a drop of here, the productivity of forest in the spring, because we had a large spring drought in April and May. You will see it coming on the black curve. And also, the summer was not so catastrophic. Everybody predicted a big drought, but it happened in late August. So as you will see on the curve, this is the April drought effect, which is prominent in the south. Nothing happened until end of July. And then because of the canicule and the drought that we had in the second half of August in the north of France, you will see at the very end of the record, in the negative anomaly, means red on the right-hand figure, that there is clearly a kind of very strong deficit of productivity, which is developing up until recently. What's quite remarkable is that we have data until last week, and we can continue to run this system. What is even better is that with our colleague from INRA, they have also near real-time flux tower measurement, so we can score our model with near real-time eddy covariance tower measurement. So for the first time, we see models living, and we can look at their performances not 5 years after when writing a publication, but in real time on a website. If it's possible to do this with a simple model for forest, you can do it for crops. The advantage of the 10-meter resolution data is that we can cross it with the RPG database, and we can have the GPP of each field of maize, corn, soybean. So we know exactly the type of crop which is grown by farmers, and then we aggregate to calculate here the photosynthesis of wheat. And we were quite surprised to find that although this model is simple and also GPP photosynthesis is not equal to yield, across the department, when you compare the prediction of the model for photosynthesis based on satellite and climate, and the yield data from the Agrest survey from the French Ministry of Agriculture, there was a very good correlation spatially. You are going to tell me, yes, okay, Philippe, but it's normal. In Larzac, we have a yield of 2 tons per hectare, and in Boss and Brie, we have a yield of 10 tons per hectare. That's what you see with your model. Fine. But the graph on the right hand is maybe more interesting. We look here at the anomaly of yield versus the anomaly of GPP. So yield is the Agrest data, and GPP is a satellite model between a dry year, 2018, and a wet year, 2021. And you can see that this model, driven only by climate, shows a good ability to predict and then perhaps to forecast in the future the anomaly of yield, not only the spatial mean patterns of yield across France. So we hope to use it now in a more like near real-time analysis and forecast, because it works much better than even crop models, and of course much better than global models which don't have crop parameterization. Another highlight, I'm doing myself, I'm a bit selfish here, but we've been doing also some work to try to map high resolution biomass and height of forest in Europe and France using a deep learning. The idea here is that there is a deluge of satellite data, you have the Sentinel-2 data, optical, multispectral. Sentinel-1 is a radar with a frequent revisit, and you have a JEDI, which is a LiDAR that measures the height of forest, but only over selected points. So we use deep learning to smartly gap fill the height, which is measured by the spaceborne LiDAR using the other images, and we produce the first height map, or map of height of forest at 10-meter resolution, which was transformed into a map of biomass. Biomass at 10 meters doesn't make any sense. You follow the tree, you get 2,000 tons per hectare. You follow the gap, you get 0. So we aggregated the biomass retrieval at 30 meter spatial resolution. And compared to independent values, because it's easy to make satellite maps, we were quite pleased to see that when you compare our height prediction over the more than 7,000 NFI plots from IGN, they measure the height of forest in situ with a 5-year visit of 7,000 plots every year. There is a very good correspondence. All other satellite models will have a mean absolute error of 5 to 10 meters for 10-meter height, and our model has, still some scatter, but the mean bias was no larger than 3 meters across a large range of forests in France. And we've been also looking at changes, because it's good to have biomass, it's very important. But as you may know, we have a problem for forests in Europe. And our advisory panel told us that we were not looking enough at forest. Indeed, the forest carbon sink that was once significant, like in France, forest absorbed 15% of the fossil. So they did a very strong climate service, and they are important in the kind of Paris Agreement declaration of a country like France. In the time of 5 years, from 2015 to 2020, from the National Forest Inventory, our forest carbon sink has collapsed by 40%. When you look at regional data, you find that this is due to lower growth. So the trees increment is smaller than before, and it is due to increased mortality. from drought, from pathogens, from the bark beetle attack in the east of France, and also from increased cutting. And we wrote this report for the Science Academy. It was almost a scandal because the forestry sector doesn't want to hear that we should cut less wood. And they say, yeah, we cut more wood because it's not our fault. We have attacks of pathogens, we have drought, we have to salvage the wood. It's not us who want to take more wood for the economy. But the point is that the French law for neutrality has based its predictions to reach neutrality based on a sink that was estimated at 50 million tons of CO2. Today, the sink is 30 million tons of CO2, and they wanted to take out more wood from forests to do substitution. So if your expectation is to continue to take wood and your baseline sink is 40% lower, if you continue with the wood extraction, of course, France will be a source in 5 years. We wanted to point this out. And we found out that this is a generalized problem. The European Commission opened the Pandora box because before they wanted to reach carbon neutrality, 40% less emission by 2030 compared to 1990, only by playing on the industrial and transport sector. But recently, I think in 2021, they decided to put in the land use sector, and they said, okay, we are not going to do minus 40%, but minus 55%, the more ambitious reduction by 2030. But this time we are allowed to include our land use sector. And when you think about land use sector, the main sink is forest. And all over European countries, the same story that in France, although a bit less dramatic, the carbon sink of European forest has decreased by 15% between 2015 and 2021. France is minus 40%. We are more affected than other European countries. But many countries like Sweden and Finland, they also observe that there is no more forest increment, or the forest increment is slowing down, and the wood harvest is continuing, increased climate disturbances, and that will lead Europe not to meet its climate targets. So it will be another, like political earthquake if, European countries often cannot agree on many things. They agreed to do this climate target. They counted on a sink of 300 million tons of carbon, and the best estimate we can do, because of the recent climate change effect, is an uptake of 240 million tons of CO2. So we are way below what was planned in terms of forest carbon sink. And unfortunately, we are looking at things with the review mirror, because the National Forest Inventory Services are only measuring today the forests that were previously measured in 2017, which means that we only know what has happened in 2019 and 2020. But the recent drought of 22, we will discover it in the successive revisit of the AFL. We don't know how badly it has impacted the forest biomass yet. So that's the reason why we also worked with satellite data to make the first map of annual forest disturbances in France from Landsat data over the last 35 years. And we attributed those disturbances using NFI data. We are working with the National Health Department of Forest at INRA in Bordeaux. And we segmented all the Landsat perturbations over French forest into different types where mortality happens because of biotic dieback, just biotic attacks like defoliation, but not dieback, drought, firestorms, and tree logging. And using the same kind of satellite technology than the one we use to make the high-resolution map of height and biomass in Europe, we have tried to use annual satellite measurements to do height changes. Height changes is more challenging than height because the trees are not growing quickly. If you take a mature tree, it's going to grow by a hardly detectable amount. On the other hand, if you cut a forest, you should see a very strong decrease of height. And if you have a young forest in a good plantation, like in Leland, you should see an increment of height. And that's exactly what we see. You see some parcels of forest that have been deforested by a clear cut here. It's a red areas. You see some parcels of forest that have been thinned. It's a light red area. And we do see a growth signal, at least in a young forest, which is interesting because, you read in the newspapers that there is deforestation in Brazil and Indonesia, and European and American scientists and NGOs are spending a lot of money to monitor what the Brazilians are doing and to say, oh, Bolsonaro, you are cutting them. Fine, this is fair enough. But in France, we don't have this. And, would you be happy if the Brazilian Space Agency would say, look, we have developed a monitoring system and we can track all the clear cuts and you are clear cutting more than what you say. In France, it's a secret. The only clear cut is from the National Forest Inventory. It's one global number. They make the average of the harvest. They don't tell you which land on earth is clear cutting the forest or planting the forest. It's a big deal because the French ministry is going to spend money to replant trees. But what can happen? You have 3 billion of forest owners in France. What can easily happen is that people will clear cut their forest. They will be unnoticed because there is no monitoring. They will plant trees, so they will cash money because they have planted 1 billion trees in total. But in the end, you have a big carbon loss. That's why I'm really kind of very active to try to develop an annual French monitoring system. It doesn't make everybody happy, let me tell you. But I think we need that. We cannot just blame others for deforestation and not have at home an accurate carbon monitoring system for forest. So the last year of Celan, sorry, I'm running slightly behind time. Yes, we have spent money, we have hired PhDs, we have continued the support of masters. We had the pleasure to see some PhDs that were funded before. It's like the forest inventory. Huh? You do a first visit and then you see the PhDs defended 3 years after. We had a bit of a kind of, gap of activity because our project manager left and hopefully will be replaced. But we have the pleasure first to have hired Yasmine Badran. She's here. And she took over the work of Louise Darmoncourt as a project assistant. She even did more because she also helped with the financial aspect, the organization. So, Yasmine, thank you very much for everything so far. As I said, because we had a bit of deficit in the project management organization without the project manager since now 8 months, we were able only to organize one, but a very good workshop with Francesco Acatino. We hope to do better next year. And last but not least, we performed interview, then we will hire as a permanent position at CEA, Fatim Ankar. And Fatim, you want to introduce yourself shortly? She has to wait for the PA administration, but she will become the new freelance project manager, hopefully end of the year.
Thank you. Thank you. Can you hear me? Okay, so thank you to give me the opportunity to introduce myself today. So I'm Fatim Ankar, and I used to be a geophysicist. I did my PhD in IPGP in the Climate Lab. After my PhD, I had several postdoctoral positions in France, Cerege, south of France, UPLC, now Sorbonne Université. And I had the opportunity to go for 3 years to Michigan, at the University of Michigan, Ann Arbor. I said opportunity because I combine research and teaching. So I was teaching plate tectonics to undergrad students and training people also. Coming back home, while I was looking for some permanent job, Jérôme Gaillardet asked me if I could help him with the Oscar project. That is, I think you guys know what Oscar is, the critical zone observatory. So I helped Jérôme Gaillardet for 3 years and a half. And currently I'm doing the same thing. So I'm a project manager with physicists, in real physics. So I've been doing that for helping Yann Lecoq and François Vernotte for 3 years now. And so hopefully I'll be with you very soon. So thank you.
Thank you.